Test is coming. This is what's going to be covered on it. We're going to study today and tomorrow. Please look over these things as we go through this review. We're going to revisit this YSU final exam review as the year goes through. So expect just to keep this in your notability so that we can write on it and mess with it here and there. Let's start with problem number 4. The first thing I'm going to ask you on the test is about just function composition. You guys know how to do that. So let's start with number 4, f of g and g of f and the domains. Now, remember, f of g, you are going to put the g function into the f function. So in this case, our g function is the square root of x. So it's 1 over the square root of x squared minus 1. Now, when you square that square root, it's just 1 over x minus 1. Now, let's talk about the domain for a minute. You have to do it in pieces. You have to look at what is the original domain of your inner function. So our inner function is a square root. The domain of that is that the inside has to be greater than or equal to 0. But if we think about our resulting function, if we look back at that function, we know that x is not allowed to equal 1 because that will screw that up. So we have to combine those things when we are making our domain. So our domain for f of g, we would be able to include and start at 0, but when we get to 1, there is a problem, so we do have to skip it, and then we can keep going. Okay. Now, let's talk about g of f. Okay. So if we go the opposite way, g of f, and I'm sorry there's not a lot of room, just do what you can to fit it in here or make a new page or something. If we look at g of f, this time we're putting this function in the f function into the g function. Now, what's our inner function? Well, that's that 1 over x squared minus 1. What two values mess that one up? What values mess up 1 over x squared minus 1? Where are our discontinuities? At 1 and negative 1. So we know that x is not allowed to equal plus or minus 1 right off the bat. Okay. Now, when we plug it in, we get that this answer is the square root of that fraction. So then we also have to think to ourselves, okay, well, what makes the square root work and not work? Well, that the inside has to be greater than or equal to 0. Okay. Now, we already know we have to skip positive 1 and negative 1. That screws up the original. But where is the inside greater than or equal to 0? That's a plus or minus chart, unfortunately. Okay. So if we look at the zeros, we already know that 1 and negative 1 have an issue, right? We know that. Okay. And so where is 1 over x squared minus 1? Well, 1 is positive everywhere. So we're really looking at x squared minus 1. What's happening there? Now, you can break it up to be x plus 1 and x minus 1 if you have the urge. I'm going to be lazy and not do that, but I'm going to plug in test values of negative 2, 0, and positive 2. Negative 2 squared is 4, minus 1 is a positive. 0 squared minus 1 is a negative. 2 squared is 4, 4 minus 1 is a positive. So this region is positive, negative, positive. So I get that my domain of this, I can have anything from negative infinity up to negative 1, and then from 1 to infinity, and that's okay. Okay. Now, I'm not going to give you ones about the domain. I just ask you to compose the functions. What's f of g, g of f of f, things like that. Okay. So hopefully that shouldn't be an issue for you. As long as you understand how to compose the functions, you got the first few problems on the test. Okay. I didn't ask about domain, but I do want to review that. Okay. Now, the next thing on the test are limits. So let's go down to number 7 for a moment. And let's talk about limits. That's the next part of your test on Wednesday. There's going to be 4 limits, and I want to talk about some strategies, okay? So I do want to talk about, let's look at B for just a moment, okay? Now, I didn't do any limits to infinity. These are just limits at certain values. So the first thing you should always check, let's look at B. Let's check what happens when you plug in. Remember, we always try direct substitution and hope for the best. If you try direct substitution, you do get, for this particular one, 0 over 0. Now remember, 0 over 0 tells us there is a hole that we have to fix, okay? If we get a number over 0, remember that's a vertical asymptote that we might be getting positive or negative infinity, but 0 over 0, there's just a hole. We can fix that. We can find that removable discontinuity, remove it, okay? Now, for one like B, anybody tell me what you think we could try to fix the problem? That's a vertical asymptote. So if you get a number over 0, we're going to try a value to the left and right of it. But if it is a whole 0 over 0, we got to try something else. Yes? Yeah, we can factor this. There is a formula, a cubed plus b cubed is a plus b times a squared minus ab plus b squared. Okay. If this happens to be a minus, this becomes a minus and this becomes a plus. I did not put a perfect cube. It's just the ones I put are factorable just because they're quadratics, nothing funky, okay? But let's factor it. So this becomes x plus 1 times x squared minus x plus 1. And then this bottom factor is to be x plus 1 and x minus 5. Now, if you're approaching -1, x plus 1 is causing the problem 99% of the time. If you're approaching +1, x minus 1 is causing the issue. So you should be able to kind of look for what's causing the issue should be that 0 factor thing, okay? So now cross it out. That's what we want. And now try direct substitution on our reduced version. So if I plug -1 into the top, I get 1 plus 1 plus 1. And if I plug -1 into the bottom, I get -6. I get 3 over -6. The answer is -1/2. So you can tell that, you know, it becomes much easier than, you know, what it was initially. But you have to remember how to factor, and only if you get 0 over 0, okay? So always check, is it a vertical asymptote or is it a 0? Let's do one like, let's do F, okay? Now F, if you plug in 7, you get 98 over 0. So it is not a hole that you can repair the issue. That has to be a vertical asymptote. So there's one of 3 answers that you get every time this happens. If you get a number over 0 and you have found a vertical asymptote, your answer is either positive infinity, negative infinity, or does not exist. Always, it's one of those 3 things. So even if you guess one of those 3 things, you have a 33% chance of getting it right, okay? So, but how do you know what? Now here's where we're going to plug in something to the left and to the right of that to see what's happening. So I'm going to plug in to the right of 7. I'm going to plug in 7.1. And I'm going to look, am I going to get a positive answer? Am I going to positive infinity? Or do I get a negative answer? Am I going to negative infinity? Okay, so I'm going to plug in 7.1. Okay, if I plug in 7.1, I get a positive number on the top. You just really care about, am I getting a positive or negative? That's all you care about. And I get a positive number on the bottom. The right side is going to positive infinity. But they didn't ask the right side, they asked simultaneous, okay? So now we're going to go to the left side. So what's going on the left side? If you plug in 6.9 on the top, you get a positive. If you plug in 6.9 on the bottom, you get a negative. You're going to negative infinity. So this one, if you're just asking what's happening at 7, one side's going up and one side's going down, this is a does not exist. Okay. So if you do not specify, they would have to match both positive infinity, both negative infinity. Okay. Does that kind of make sense how that works? Okay, now I want to do a square root one. Everybody, let's take a look. Let's look at O. Let's look at O. First thing we always try is direct substitution. So if you plug in 1, you get 3 minus 3 or 0 on top. You get 0 on the bottom. There's a hole. I need to fix it. Well, for a square root problem, we fix the hole by using the conjugate. So just surround top and bottom by parentheses. Multiply the top by the square root of 8 plus x squared plus 3 on top and bottom. Okay? Okay. Now, when we do this, on the top, that's just the difference of squares. So it's just the first term squared minus the last term squared. That's why they're conjugates. Conjugates are always the difference of squares. So just square the first thing, square it minus the square of the last thing. If I square a square root, the square root pops off. That's just 8 plus x squared. If I square 3, I get 9. So it's just minus 9. And then here, just leave it alone, leave it alone, leave it alone. If it is not a conjugate, whether that happens on top or bottom, leave it alone, leave it alone, leave it alone. Okay. Now, on top here, this is x squared minus 1, which is x plus 1, x minus 1, which means I can cancel out the thing that caused the issue. If I'm approaching 1 and I get 0 over 0, x minus 1 should appear in the problem somewhere. If I'm approaching 2, x minus 2 should appear in the problem somewhere. Okay. So now I'm left with x plus 1 over the square root of 8 plus x squared plus 3. Now, I can try plugging in 1 now because it should work. I should just be able to now use direct substitution. On the top, I get 2. On the bottom, I get the square root of 9, which is 3. 3 plus 3 is 6. The answer is 1/3. The answer is 1/3. Okay. So there will be some that you will have to, you can just do direct substitution. Some you're going to get 0 over 0. Some you might find a vertical asymptote. Those are the limits. Okay. Okay, now please, could you jump to some derivative ones? Well, we'll just start with, let's start with 12. We're just going to do some derivatives, remind you of the rules. So the next part of the test, I have given you 1, 2, 3, 4, 5, 6 equations, and I say find the derivative. Okay, and they're just either, many of them are, they do require some chain rule to remind you of that. Okay, so let's look at some. We're going to do just quite a few derivatives. We'll just, churn out some derivatives now to remind you of those rules. Okay, so let's look at number 12. The first thing you want to do when you are doing this derivative, remember those rewrites that help us make the derivative much nicer. So let's rewrite that 7 times x to the 4th minus 15 to the negative 1/2 power. So if you can write a quantity to a power, we can use either the power or chain rule or a combination of the two. So y prime is just the chain rule. So we're going to drop the power down in front. The power goes down by 1. The stuff stays there, but then don't forget to multiply by the derivative of the stuff. Okay? Okay, so the power drops down in front, multiplies by the 7 that's there. So that's negative 7 halves. Stuff stays there. Stuff stays there. Stuff stays there. The power goes down by 1. Multiply by the derivative of the stuff. So that's 4x cubed. Now, they wanted to find the derivative when x is equal to 2. For me, when you differentiate these, I did not plug in any values. I just said find the derivative. So that's where you would stop. I do not care about simplification purposes. I don't care. Just do the derivative, okay? So let's continue. I know we could continue, but same thing for 13. They wanted the derivative at 5. I don't care about that part. Let's just practice the derivative for number 13. First, let's do a rewrite. Let's make this 2x plus 17 to the 2/3 power, so then we're able to differentiate. Now, again, most of the ones that I put on here do have a chain rule component very similar to what we see right here. So what is y prime? Well, we drop the power down in front. Yes, see, okay, so no, let me remind you the rules. That is our numerator. The index is your denominator. Yeah, so write it as a fractional power so then we can just lump it all together. Okay, so drop the power down in front. Stuff stays. Power goes down by 1. 2/3 minus 3/3 is negative 1/3. Don't forget to multiply by the derivative of the stuff inside. Stuff stays, derivative of the stuff inside. And then, of course, they wanted us to plug in 5. I don't care about that part. Okay. Same thing for 14. Let's do the derivative. They wanted us to plug in 1. I don't care about that part. Okay. There is a rewrite for this problem that you might not notice, but I did want to remind you. I would rewrite this as 8/3 times x. Pull that x apart. Same thing, I would pull the x out of this one, but our x is in the denominator. Let's make that a negative 1. Okay. Now do the derivative. So the derivative for this one, 8/3 x is just 8/3. Remember, the constant on x is just the constant when you take the derivative. Power drops down in front, so that's going to become a positive 3/8 x to the negative 2. That's the page number. Ignore that. That is not my writing. I wish I could make it do that pretty. Okay, so yeah, it doesn't look very good, does it? Let's scooch it over there. Okay, so that, hopefully you remember that. Let's do one that is a product chain rule. Let's do 15. Again, they wanted us to find it when x is 1. I don't care. Okay, so let's rewrite this as 2 minus x and x squared plus 8 to the 1/2. Okay, we're going to put a noticeable dot between them because we want to remember that that is a product rule. The product rule: first times the derivative of the second plus the second times the derivative of the first. Okay, so the derivative: first times the derivative of the second. Well, the second is a thing that's trapped. So power goes down in front, stuff stays, power goes down by 1, times the derivative of the stuff inside. Now we're going to do the second, leave it alone, times the derivative of the first, which is just a negative 1. Always use parentheses, guys. I know sometimes you guys won't put it in parentheses. It can change the meaning of actually the mathematics, so please, parentheses are helpful. Okay, so that is some derivative stuff. They're not going to be anything much more difficult than that. Some of those are a little even harder than what I put on the test. Now I would like to talk about equations of a tangent line. Not yet. Let's first find some implicit differentiation. Guys, everybody, let's go to 27. Let's go to 27. It says, find y prime at 1, 1. Now, on the test, I just said find y prime, okay? Find y prime. So it is your job to actually, okay. So let's do this. For this one, the only thing I would suggest is if an x and y are touching, please put a dot between them so you remember to do the product rule. Every time we take a derivative of a y, what do we got to put on there? Y prime. Okay. So let's do the initial thing first. So we get 4y cubed, y prime, okay, plus 4x cubed. Now, minus the first times the derivative of the second. That's a y prime. Plus the second times the derivative of the first. I'm going to attach that -2 to the x squared and make it -4x. The derivative of 9x is 9. The derivative of 9 is 0. Now, I want you to actually solve for the dy dx or the y prime. So once you got that, remember every term that contains a y prime, we're going to leave on one side. The terms that are not y prime, we're going to move to the other side, okay? So if we do that, we get 4y prime minus 2x squared y prime. We're going to get a -4x cubed, a positive 4xy, and a -9. And those can be in any order, so don't worry about that as long as the sign is correct. Remember, at this point, I'm sorry, that's a y prime. And you're going to always do the next phase by factoring out the y prime, put in parentheses what's left, and then we're going to take that quantity and just divide it, and you're done. So our answer is y prime is -4x cubed plus 4xy minus 9 all over 4y cubed minus 2x squared. So there is one like that on the test, okay? Now, there's also one where we have to use implicit to find the equation of a tangent line. So let me find one like that. Is 18 like that? Oh, perfect, thank you. Okay, so everybody, let's look at 18. I need to add a sheet of paper so that we can. So we're going to do 18 at this time. So it says to find the slope of the tangent line at the point. We're going to actually find the equation of the tangent line. Okay, so we're going to do both. We're going to find the slope, yes, but we'll find the actual equation as well, okay? So the first thing we do is exactly what we did in the last problem. You got to find y prime, okay? But what's great about this is we actually have a point. So that's a good thing, okay? So we're going to take our x squared plus 2x y squared, put a dot between those two. Don't forget that part, okay? So we get 2x plus first times the derivative of the second plus second times the derivative of the first. And then 3y's derivative is 3y prime equals 0. So we just took the derivative, nothing fancy, okay? Now, what you're going to do at this point, it's up to you. But see how we have a point? Why not take out the x's, replace them with 2's? take out the y's, not the y primes, but the y's, and replace with negative 3. I mean, they're numbers, okay? So this would be 2 times 2, 2 times 2, times 2 times negative 3, y prime, plus negative 3 squared times 2, plus 3y prime equals 0. They're just numbers. So every x's I replaced with 2's, and all the y's I replaced with negative 3. Okay, so hopefully I think I did all that right. Okay, so let's just make these numbers so that we don't have to deal with anything but a y prime. It's our only variable. So we get 4, negative 24 y prime. 9 times 2 is 18, plus 3y prime equals 0. Okay, so it's just an equation, which is great. Okay, so let's, 4 plus 18 is 22. So that's negative 21y prime plus 22 equals 0. So negative 21y prime equals negative 22. Y prime is negative 22 over negative 21, or 22 over 21 is our slope of our tangent line. Yay! Okay. Now, that's the hardest part. Remember, the first thing we do is find y prime. The second thing we do is plug in some numbers so we actually find the slope. The third thing we do is y minus y1 is m times x minus x1. We always do the same thing. We've done part 1 and 2. We found y prime. We stuck in numbers so that we got an actual number for the slope. So now it's just the point slope formula. So we're using the point 2, negative 3, and the slope 22 over 21. I don't expect you to simplify it because I don't care. I know how, you know how fractions work and all that good stuff. So it would be y plus 3 equals 22 over 21 times x minus 2. And that's our answer. Okay, so expect to know how to do the equation of a tangent line, but with implicit differentiation. Okay? Any questions about that? Okay, so that's over half of the test right there. I do want to talk now about, I just got to find it, some related rates where it's all set up for you. You don't have to, set up anything. Do we have any related rate ones on here that are set up for us? Stop, we'll get to those. I was hoping there's one where related rates are set up for us. Okay, so let me give you an example. I need a calculus book. Bringing out the book. No, this is just a cumulative test for you guys. It's just a test. Okay, so let's find, I want a related rates problem that's already set up for you, because you guys overthink these and they're actually really nice because they're already set it up. Don't. Okay. Here we go. Okay. Ready? So if we have, I don't want it to be the same problem as on the test. Okay, here we go. So let's say that we have x squared plus y squared plus z squared equals 9. Dx dt equals 5. dy dt equals 4. Find dz dt when x, y, z equals 2, 2, 1. Okay, so let's think about our dreads problems for a moment, okay? Dreads, draw the picture, find the rates and the equation, and then differentiate. Problems, or steps 1, 2, and 3 are done in a problem like this. You don't have to draw a picture. They've given you the rates in the equation. You just have to differentiate and then solve. So you're ready to go. Don't make this harder. To differentiate with respect to time, we're going to tack on for an x, dx dt, for a y, dy dt, for a z, dt dt. So you just differentiate. So if we differentiate, we get 2x dx dt plus 2y dy dt plus 2z dz dt equals 0. Now we know the point, 2, 2, 1. We know dx dt, we know dy dt. To find dz dt, just got to plug all that junk in. We got it. So these are so super easy. And then when you guys miss them, I'm like, wait, it's all set up. Don't make it harder. Okay, so we're just going to take out the numbers, plug them in. So x is 2, dx dt is 5, y is 2, dy dt is 4, z is 1, dz dt is the thing, and the only thing that I don't know. So it's just a very nice math equation at this point. 2 times 2 times 5 is 20. 2 times 2 times 4 is 16. 20 and 16 is 36, but I'm going to move it to the other side of the equation because I'm running out of room. So it becomes negative 36. Divide by 2. Guess what? We got dz dt is negative 18. That's it. So don't make these ones harder. I've given you one where it's all set up. It's ready to go. You just have to do implicit differentiation, plug the numbers in, you got the answer. Okay? So please don't make these harder than they have to. What happens when you're using implicit differentiation when the x and the y are touching? What do you have to do? Add a dot. Okay? That's the biggest thing, is the one that I gave you, there's an x and y touching. So you have to add a dot so you can use product rule. Okay, so that's the biggest part of the test. That's everything. Okay, so now let's talk about the next. There are just a few more problems. And this is what your test is over. Okay. So, I'm finding some here. Okay. So if I say, everybody, let's go to 36. Everybody, let's go to 36. See how it's find the absolute maximum on an interval. There is one like that on the test. Okay, where I've asked you to find the maximum on an interval. This actually should be, because I know that you guys know this stuff, it should also be a pretty straightforward process. But you guys tend to overthink it. And you just, I don't know, your mind goes blank or something. Let me remind you of the rules, okay? So the first thing you want to do is you want to find the derivative, okay? The next thing you want to find are the critical numbers, okay? The third thing you want to do is you want to plug in the ends and the critical numbers that are in the interval. And then you label them max or min. That's it, okay? You guys tend to make these problems so much harder than they have to be. There's no reason they have to be hard. Now, 36 asks you to find the maximum and minimum values on 2 different intervals because they're trying to show you sometimes you there's some values that are excluded because it's not in the interval. Let me show you what I mean. The first thing we do is we find the derivative, which is 3x squared minus 12. The second thing we do is we find the critical numbers. The critical numbers are where that derivative either does not exist or is undefined, but works in the original function. Now, that function doesn't have any undefined points. It's a polynomial. But where does 3x squared minus 12 equal 0? Well, that's a factorable quantity. If you factor out the 3, you see that x we have critical numbers at -2 and +2. Now, step 3 says to plug in the ends and the critical numbers that are in that interval. So let's take a look at our first interval that we're checking, 0 and 3. Is -2 in the interval from 0 to 3? Is -2 in the interval from 0 to 3? No. Is 2 in the interval from 0 to 3? Yes. So we have to take our original function and we have to plug in the endpoints and the critical numbers that are in that interval. So only 2 gets used. And we're plugging into the interval or into the original because we're checking, does it work back in the original? Okay, if we plug 0 into the original, we get 0. If we plug 3 into the original, we get 27 minus 36 or -9. If we plug 2 into the original, we got 8 minus 24 or -16. This is our maximum and this is our minimum. So that's step 4, just to label them. Okay. Now, if we check the interval from -3 to 0, there's only one difference. What 3 values do we plug in this time? -3, 0, and -2. See the difference? The interval decides what critical numbers are necessary or valid based upon the interval we're checking. From 0 to 3, you always check the 0 and 3 and 2 this time. But for -3 to 0, we check -3, 0, and -2. See the difference? You're just checking. So if we plug in -3, we get -27 plus 36, which is 9. We already plugged in 0 and we got 0. When we plug in -2, we get -8 plus 24 or 16. So this time, this is our max and this is our min. So please make sure that you are finding the critical numbers and only using the critical numbers that are in that interval when you make your decision as to which is the max and which is the min. Okay, so that is one of the problems you'll have on the test. Okay, now let's go back up. Do we have any questions? Is that one good? Okay. Is there anyone that mentions Rawls theorem? I need the Rawls theorem and the mean value theorem. Is that mentioned anywhere here? Oh, I bet you mean like on that thing. No, I might take those ones out. Okay. It was okay. So no, never mind. Okay, so let's do increase and decrease in local mins and maxes. Increase and decrease in. Find a local max. Is there say where it's increasing or decreasing? Concave up, intervals, concave down, decreasing. Okay, so let's Let's do the ones where they say to find the local mins and maxes. So guys, let's do 34, but we're going to do increasing, decreasing. We're going to do local mins and maxes. We're going to do everything for 34. So then I can kind of tell you exactly what I'm looking for. Okay, so everybody, we're going to do problem 34. I'm going to ask you a few more questions about 34. Okay, so if they just say local mins and max, not on an interval, but just where's the local mins and maxes for this function, we have some things we got to work on. Okay, so what you want to do is you want to find the first derivative. You need to make a plus or minus chart, and then you can analyze maxes and mins from there. Okay, so that's kind of what you want to do as you go through this process. I chose a really disgusting one. Is there one that's any better? Okay, we're going to do 35 instead of 34's gross. I just saw the answer for 34 and I'm like, let's do 35 instead. But again, we're going to answer all the questions about it. Okay. So it says to find all the local maxima. So local max and mins are from the first derivative plus or minus chart. Okay, so anytime you see that without on an interval, you have to make a plus or minus chart. Okay, so the first thing you want to do is find the first derivative. Well, 4 drops down in front times the 1/4 makes a 1. That's great. So that's 1x cubed, and then minus 5x plus 0. So that's a nice first derivative. So remember, after you do that, we have to find any critical numbers because that's what we have to put in our plus minus chart. Well, x cubed minus 5x equals 0. However you find it, the critical numbers are at 0 and plus or minus the square root of 5. That x squared minus 5 didn't come out to be the greatest number in the world, but you know, okay. So if you look in a calculator, the square root of 5 is roughly 2.2. So when we go to test values, -3, -2, +2, and +3 should work just fine. Okay. Now these are nice points. They exist. Our original function is a polynomial. All these points work just fine and are great and are lovely. So I put a little dot there to remind me, hey, those are points. They work. There's something. So it's either local mins or maxes. What's happening? Okay. Okay. If we plug, and you can break this down into those 2 pieces, these 3 pieces, all of that, it doesn't matter. I'm just going to write this over here. If I plug in -3, I get -27 plus 15, which is a negative. If you plug in -2, you get -8 plus 10, which is a positive. If you plug in +2, you get 8 minus 10, which is a negative. If you plug in +3, you get 27 minus 15, which is a positive. Okay. So let's answer the question about local mins and maxes, increasing, decreasing. We're going to label everything. Okay, so it's increasing from those intervals, from negative square root of 5 to 0, and then from square root of 5 to infinity. Now you're not supposed to put a bracket there because those points are your switchover points. So I don't put a bracket there. If you put a bracket, I don't really care for that. Okay, decreasing. That would be those pieces. So from negative infinity up to negative square root of 5, and then from 0 to square root of 5. So what does that tell us about the points in question? Well, we are decreasing and increasing. What is negative square root of 5? Local min, local max. Okay, so that's a local min at negative square root of 5. Now let's talk about 0. It is increasing, then decreasing. What's 0? Local max. And then we got this point. It was decreasing and increasing. What is square root of 5? Yep, it's a local min. So local mins and maxes, if they don't specify absolute maximin on an interval, you're just doing the first derivative plus or minus term. Okay? Does that make sense? Are we good with those? Now let's talk about concavity and inflection points. Well, we'll do that tomorrow. But please study. This is what your test is over. This is 90%. What we just finished 90% of it right now. Okay? So we only have a little bit more to talk about tomorrow.